a subtraction of two complex numbers, right? So as I have a subtraction of complex numbers, remember that a complex number have a real part and an imaginary part. So when I have this number 9 plus 3i, this part over here is called real part. And this other part is called the imaginary part. So if I want to do either an addition or subtraction of complex numbers, I have to combine real part with real part and imaginary with imaginary. So I cannot mix a real with an imaginary. I cannot combine a real part with an imaginary part. So what I'm going to be doing here, I would be removing the parentheses first. So we say I will remove the parentheses of 9 plus 3i. So the sign here in front of this parenthesis is positive because there is no sign. So we say that this is 9 plus 3i. And then in front of the second complex number, we have a negative sign. So this negative sign will make you reverse the signs inside. It's like you multiply the number inside the second parenthesis by -1. So you say -1 times -7, this is +7. And then -1 times +i, this is -i. Right? So I got 7 minus I. I have to reverse the signs inside the second parenthesis. So now, what are we doing next? We are combining real part with real part. So what are real? 9 and 7. They are both real parts, right? So 9 plus 7, 16. And then now, I am combining 3i minus 1i, right? Minus I is basically minus 1i, okay? So 3i minus 1i, positive 2i. So what is the result of subtracting the number -7 plus I from 9 plus 3i? The result would be 16 plus 2i. Exactly, as we can said, this is answer C, right? Now, in the second example number 2 here, what happens? What we have now here is an addition. So it's going to be basically the same, except that in this case, I don't have to reverse the signs in the second parenthesis, right? Because the sign in front of the parenthesis is positive. So I will be removing the first parenthesis, 4 minus 9i. And then when I remove the second parenthesis, 6 is positive, 7i is positive, so they stay like that. Okay? So now, 4 plus 6. We're going to be adding real part with real part. What is real part here? 4 is real part. 6 is real part. So 4 plus 6 is 10, right? And then negative 9i plus 7i. Negative 9 plus 7, negative 2, no? So it's going to be negative 2i. So what is my answer? 10 minus 2i, which is also answer C. Right? So you got it? So remember, when we are adding or subtracting, we are going to remove the parenthesis first. If negative sign in front of a parenthesis, you must reverse the signs inside. Right? Then, after removing the parentheses, what are we doing? We are combining similar parts. So we have to differentiate the real part from the imaginary part. Real part is that part that is just a real number. The imaginary part is the part that contains also the I, so the imaginary unit. The imaginary unit, okay? So just remember that. Now, let's work in these multiplications and the divisions. So may I just move to the next exercise? May I move to the exercise 3, 4, and 5? Okay, good. So now, let's work in these two exercises, 3, 4, and 5. try to work a little bit for yourself. So I will give you a few minutes, so you can just think about the solutions. You can try. At least you can just get an idea, you know how to do it, and later we can just work on the solutions. So number 3, what are we going to do here? We're going to multiply. We apply the distributive property. So we multiply 3 times 8. I will multiply 3 times 7i. The multiplication is different. In multiplication, we multiply real with real, real with imaginary, imaginary with real, imaginary with imaginary. So we later multiply 8i times 8 and I will multiply 8i times 7i, right? Okay. Do you see, can you read what I'm doing? Do you see what I'm doing? So it's clear there, so you can see what I'm doing? Okay, just to make sure. So now, when I multiply, I say 3 times 8, right? Plus 3 times 7i, okay? Now, plus 8i times 8, right? These two. Plus 8i times 7i. So 3 times 8, 24, plus 3 times 7i, 21i, right? 8i times 8, 64i. And 8i times 7i, 56i squared. 56i squared. Now remember, I squared is equals to -1. So I will basically substitute this I squared times -1. So this will be minus 56, right? So that means that I get now 3 times, 24 plus 21i plus 64i minus 56, right? Because positive 56 times -1, negative 56. Now I will combine real with real. So 24 minus 56, minus 32, right? 24 minus 56 is negative 32. Huh? So subtracting 4 from 6 is going to be 2, and subtracting 2 from 5 is going to be 3. So this is minus 32, right? And then 21i plus 64i, that is 50 or 85. So 85i. So what is the right answer then? Answer D, right? Answer D. So remember, you cannot leave it like I squared. They give you one answer here with I squared. This is to confuse you, right? Because this is the answer. If you don't remember that you have to convert this I squared or replace this I squared by -1. So you get minus 56, and you later combine the 24 minus 56, right? If you don't pay attention to that, you can pick this answer, which is wrong. Answer B is wrong. So right answer here is answer D. Now, the next two exercises are about division. In division, when the denominator of the complex number, or when the denominator, of the quotient is a complex number, you will multiply by what we call the complex conjugate, right? Remember, the complex conjugate. So the complex conjugate of 7 plus I is 7 minus I. The complex conjugate of 7 plus I is 7 minus I, right? So this is multiply here by 7 minus I. If you multiply by 7 minus I below, you multiply by 7 minus I above, right? Why 7 minus I? Because remember, 7 minus I is complex conjugate of 7 plus I, right? My denominator here is 7 plus I. I have to multiply numerator and denominator by the complex conjugate, by 7 minus I, right? Now, when I do that in this case, I get multiplying the numerators 2 times 7 and 2 times -5. Now below, remember there is a shortcut. Remember that there is a shortcut, right? And then what is this shortcut? The shortcut would be the square of the first, so it would be the square of 7 plus the square of the second. The second is the imaginary part. So there is a 1 here in front of the I. There is a 1. So you square that coefficient 1 that you have in front of the I. That is the 1. So you square that coefficient 1 that you have in front of the I. That is the imaginary part. So you say 7 squared plus 1 squared. If you want, you can say 7 times 7, 49. 7 times minus I, minus 7i. I times 7, 7i. 7i minus 7i, 0. I times negative I squared. Negative I squared, as I squared is negative 1, would be negative 1, which is going to be positive 1. You get the same thing. So if you multiply, you FOIL 7 plus I and 7 minus I, you will get the same thing, right? But you can use this shortcut, right? Now, what I get? 2 times 7, 14, minus 2i over 7 squared, 49, and 1 squared, 1. So this is 14 minus 2i over 49 plus 1, 50. Now, can you leave it like that? No. You have to separate the real part and the imaginary part, right? So I will divide 14 by 50 and 2i by 50. Of course, you will simplify now. Huh? So when you simplify, here you say dividing by 2, right? This will be 7. Dividing by 2, this will be 25. Dividing by 2, this will be 1. Dividing by 2, this will be 25, right? So what do you get now? You get 7 over 25, 7 over 25 minus 1 over 25, I, don't forget the I. 1 over 25, I. So this is my right answer. This is my right answer. ¿Dónde? Aquí. Porque la regla para multiplicar un número complejo con su conjugado es la suma del cuadrado del primero más el cuadrado del segundo. Eso es 7 al cuadrado. El coeficiente que tiene la I adelante es un 1. Eso es un 1 al cuadrado. So 7 squared plus 1 squared. Eso es, this is a rule. So you have like this. Let's say that when you have A plus BI times A minus BI, this is always equal to A squared plus B squared, right? Now, who's B? B is the numerical part, right, of the imaginary term. So the imaginary part, the numerical part, the numerical factor of the imaginary part is called, or the imaginary term, you know, is called the imaginary part. So it's A squared, the square of the real part, plus the square of the imaginary part. Got it? Or it's always just like that. It's always plus. But you can also multiply 7 times 7, 7 times negative 5, I times 7, I times negative 5, and at the end you will get the same 50. Also, remember that when you multiply a complex number times its conjugate, the output here is a real number. It's a real number. So this is always a real number. Now, let's do the next one, which is exactly the same. So, well, what is the right answer here? Answer B, right? It's answer B. You have the answer key. So you can check in the answer key, right? If we are doing this correct or not. Now, look at the next one. Next one is again a division, same story. What is my denominator? 5 plus 6i. What is the complex conjugate of 5 plus 6i? 5 minus 6i, right? So it would be multiplying by 5 minus 6i above and below, right? So I multiply by the complex conjugate of 5 plus 6i, both the numerator and the denominator, right? Both are being multiplied by the complex conjugate of the denominator, right? So what I'm doing now, I will say, okay, above, so numerator times numerator, I will apply the distributive property. So we say this is 1 times 5 plus 1 times minus 6i plus 3i times 5 plus 3i times negative 6i. 3i times negative 6i. Below, we're going to say, oh, 5 squared plus 6 squared. Why? Because what is the real part? 5. What is the imaginary part? 6. So you say a square of the real part plus a square of the imaginary part. Okay? Now, 1 times 5 is going to be 5. 1 times negative 6i is negative 6i. 3i times 5 is 15i, right? And 3i times negative 6i is negative 18i squared. Agreed? Over 5 squared, 25. 6 squared, 36. Right? Now, this I squared over here is minus 1. So negative 18 times negative 1 would be positive 18, right? So we will get 5 minus 6i plus 15i plus 18 all over 25 plus 36. That would be 61, right? 61. 5 plus 6 is 11, carry 1. 2 plus 3, 5, and 1 is 6. Now, we combine 5 plus 18, 23. Huh? And minus 6i plus 15i. So minus 6 plus 15, or 15 minus 6, 9, no? 9. So 23 plus 9i over 61. Now, I will separate real part and imaginary parts. So I say 23 over 61 plus 9 over 61i, or 9i over 61. So what should be the right answer here? Answer A, right? You have the answer key, so double check my answers. I can make a mistake. We got it? So we got this? Everybody understand? All right. Now, next. What are we doing next? We are going to evaluate. So remember that I mentioned in class, right, that we know that I to the power of 1 is I. I squared, by definition, is negative 1. I to the third power is negative I. And I to the fourth power is 1. So these are the first 4 powers of I. I can give you this in the test, right? I can just put that on the board during the test, right? I to the 1 is I squared is minus 1, I to the third is minus I, and I to the fourth is 1. Now, when I have an exponent, I to the 38, I to the power of 38, and I want to evaluate that. So what are we doing? We are going to divide the given exponent by 4, always by 4. Why? Because the powers of I are repeated, the values of the powers of I are repeated, every 4 powers. So there is a pattern. such that I to the first, I to the fifth, I to the 9, I to the 13, all they have the same value. I to the second, I to the 6, I to the 10, I to the 14, all have the same value. I to the third, I to the 7, I to the 11, all have the same value, and like that. So there is a pattern always repeated every 4 powers, right? So I will divide whatever exponent they give me here by 4, right? So when I divide 38 by 4, I say how many times? 4 goes into 38, 9 times. So 4 times 9, 36. Subtracting, I get 2. This value 2 that we got is 6. Subtracting, I get 2. This value 2 that we got, that is the remainder, this becomes here the new exponent. This would be the new exponent, right? So I can say that this I to the power of 38 is the same that I to the power of 2. It is saying that I to the power of 2. And I to the power of 2 is equal to -1. So what is the answer? Just -1. So what is the value of I to the power of 38? -1. Got it? So this is answer C. So always when you are going to evaluate a power of I, what do? You divide the exponent, the given exponent, by 4. And the remainder of that division is the new exponent. That would be the new exponent. That exponent would be always 1, 2, 3, right? So would be one of the first 4 powers of I. We got it? Any questions so far? Question about the complex numbers? No questions? So do you understand the operations? Good. Now, what are we doing next? We're going to be solving equations, quadratic equations. In this case, they say use the square root property to solve the equations. And they give us 2 equations here that we're going to solve by using the square root property, right? So the first one, they give us 7x squared plus 2 equals 177. So what we want to do, remember that I mentioned that there is a principle or theorem that say that if x squared is equals a number, then x is equals plus or minus the square root of the number, right? So this is the foundation of taking the square root, you know, in a quadratic equation. So I will isolate x squared. I will try to get x squared by itself, and then after that, I will apply square root. So that means that I will be subtracting 2 from both sides. So I get 7x squared, sorry, is 177 minus 2. So 7x squared is 175. So now x squared is, I divide by 7, 175 divided by 7. So x squared is, when you divide 175 by 7, what do you get? Let me get my calculator. Okay, 25. Okay, so we get that x squared is equals 25. And then what happened? Now we have x squared equal a number. So we are ready to apply this. We are ready to apply the square root. So we say if x squared is equals 25, x is equals plus or minus the square root of 25. What is the square root of 25? 5. So x equals plus minus 5. So x equals plus minus 5. Sorry. X equals plus minus 5. That means that in this case, we have two solutions that are negative 5 and positive 5. So what is the right solution in this case? Answer B. Huh? Answer B. For exercise number 7 is answer B. Now, exercise number 8. Again, we have to take a square root. Again, we have to take a square root. But in this case, we have the square of a binomial equal a number. The square of a binomial equal a number. So when I take a square root in this case, you know, what I do is to apply a square root and I will get the binomial equal plus minus the square root of the number, right? So in this one we have 2x minus 3, which is a binomial, square equals 49. So we apply a square root and we get 2x minus 3 equals plus and minus the square root of 49. So 2x minus 3 equals plus minus 7. Plus minus 7, because the square root of 49 is 7, right? Now, what are we doing next? Adding 3 to both sides. So we get 2x equals positive 3 plus minus 7. And now we divide by 2 both sides. So x is equals 3 plus minus 7 over 2. Now, when you have 3 plus minus 7 over 2, you have two solutions, right? One solution would be 3 plus 7 over 2, which is 10 over 2, which is 5, right? And then 3 minus 7 over 2, which is minus 4 over 2, which is negative 2. We got it? You follow me? Snellby, we got it? So which are my answers? What are my solutions? 5 and negative 2, or negative 2 and 5, right? So what is the solution? Answer B. Negative 2 and 5. It doesn't matter really, you know. That means we usually put first the negative number, you know, but when you write a set, in a set there is no order. So you can have the elements of a set in any order, and that is fine. The solutions is solution set, so it's a set, right? So it can be written in any order, but as a convention, usually, you know, we put the negative sign first, the smallest number, sorry, first, the smallest number first, and the largest number after the smallest number. So, but if I write 5 comma negative 2, that is going to be okay. But usually, you know, we say, okay, negative 2 comma 5. And here they do the same thing. They just put those numbers in order. Right? But do you understand what I did over here? So when I solve for x, right, that I found the square root, I was adding 3, I was dividing by 2, I got here two signs. The plus and minus will be break down into operations, in two different fractions, right? One that involves the positive sign, that is this one, and a second one that involves, you know what? The negative sign, right? In one we have 3 plus 7, in the other one we have 3 minus 7. We got it? Any question? Martha, are you understanding this?
My answer.
Are you understanding?
Give like D.
Huh?
My answer.
Which one shows that answer? The answer key? Choose answer D?
Uh-huh.
No. Because it's positive 49, so you get plus minus 7. So this one is negative 3 positive, so passes positive to your side. So it's positive 2. But we can do a test, right? Very quick. So let us use negative 2. Let us check using negative 2. Look at this. We say 2 times negative 2 minus 3 squared is equal to 49, right? So 2 times negative 2 is negative 4. Minus 3 squared is equal to 49. Negative 4 minus 3 is negative 7. Squared is equal to 49. So negative 7 squared is 49, so 49 equals 49. That means that negative 2 is okay as solution. Now we can do the same with 5. So we say 2 times 5 solution. Now we can do the same with 5. So we say 2 times 5 minus 3 squared is equals to 49. So 2 times 5, 10, minus 3 squared equals 49. 10 minus 3, 7 squared equals 49. 7 squared is 49 equals 49. So the solutions here are 5 and minus 2. So if it said minus 5 and 2, it is wrong. These are the solutions.
Okay.
It can happen, you know, with the answer keys sometimes. You can just get some mistakes, but usually the answer key is pretty accurate. But yeah, it happens sometimes. Now look at the next problems. They say solve by completing the square. Solve by completing the square. So completing the square. How we solve by completing the square? There is a whole process that we follow, you know, when we're not solving an equation by completing the square. So I have the equation x squared plus 14x plus 30 equals 0. If I want to solve by completing the square, remember that the first would be to move the constant to the other side. So subtracting 30 from both sides, right? So we say this is x squared plus 14x equals negative 30. Okay? Now, we have to find c. We know that this value here, 14, is b. And we know that we have to calculate a number c that is equal to b over 2 squared. So it's 14 over 2 squared. 14 over 2 is 7 squared, and 7 squared is 49. So this is c. C is the number that completes the square. So what are you doing next? Next, you are adding c to both sides of this equation. So you say x squared plus 14x plus 49 is equal minus 30 plus 49. So this 49 that I calculate here is the number that I am adding to both sides, right? This 49 that I calculate is the number that I am adding to both sides of the equation. What equation? This equation. Now, when I do that, this x squared plus 14x plus 49 becomes a perfect square trinomial. So the factors of this perfect square trinomial are x plus 7 times x plus 7. And negative 30 plus 49 is 19. Why x plus 7 times x plus 7? Because what are two numbers? That you multiply, get 49, and adding the numbers, you get 14. 7 times 7 is 49, and 7 plus 7 is 14, right? So it's x plus 7 times x plus 7. These two factors needs to be equal. These two linear factors needs to be equal. So now, what is x plus 7 times x plus 7? This is x plus 7 squared equals 19. what do you do next? You have something similar to what we had in this exercise over here. We have the square of a binomial equal a number. This is basically what I got now in this case. The square of a binomial equal a number. Right? So when I have that, I will apply a square root. So we say I apply square root. So I say x plus 7 is equals plus minus a square root of 19. And now I subtract 7. So I say x is equals negative 7 plus minus a square root of 19. So what is my answer? Negative 7 plus minus a square root of 19. Answer B. So what are the good news? That in the exam, if you want, you can solve this using complete the square, but you can also use the quadratic formula if you want, right? So you don't have to really do it only by completing the square, because at the end, the exam is multiple choice. So I would never review your work, right? So if you feel confused about solving by completing the square, you can always use the quadratic formula, right? And the quadratic formula, that is the next exercise, I will show you how to use it. I will remind you now how to use the quadratic formula, right? Entonces, of course, yeah. So I know this one. Remember that I said in class that the quadratic formula had been obtained from completing the square of the equation ax squared plus bx plus d equals 0. So basically, the quadratic formula is as strong as completing the square. So there are two very strong methods that let us solve any equation, any quadratic equation. So you can solve by using the quadratic formula if you feel confused. Regardless that if the question says solve by completing the square, okay, you say solve by completing the square, but I want to solve it using quadratic formula. At the end, what I want is that you learn how to solve equations. How do you solve the equation? I usually solve the equations using the quadratic formula. So I don't spend my time trying to complete a square. So what is the quadratic formula? Next exercise 10 is quadratic formula. What is the quadratic formula? Is x equals negative v plus minus a square root b squared minus 4ac over 2a. Right? Now, what we have to do? We must find the values of a, b, and c. So here, in this equation, a is 3. Right? This one. B is 12. Right? And this value, C, is 1. Do you agree? So I can just go now to the formula and substitute the values, right? So I can say, oh, okay, great. Minus B. Who is B? 12. So minus 12 plus minus a square root of, now, negative b squared. What is b squared? 12 squared minus 4 times a times c. What is 8? 3. What is c? 1 all over 2 times 3. 2 times a is 2 times 3 because a is 3. So inside the radical we have 12 squared because it's b squared minus 4 times 3 times 1. So this is negative 12 plus minus a square root of 12 squared, 144, minus 4 times 3, 12 times 1, 12, all over 6. Now, what is next? Here you get negative 12 plus minus a square root of 144 minus 12, 132. All over 6, right? Now, what is the square root of 132? You get, remember, 6, right? Now, what is the square root of 132? You get, remember, you can you should have one of these calculators, or like this one or any scientific. But this one is very good. It's a very good calculator. So in this one, you can put exactly that square root in your calculator. You say square root of 132, and the calculator is going to simplify that for you. So when I find in the calculator the square root of 132, the calculator say that is 2 square root of 33. So I say, okay, great. This is negative 12 plus minus 2 square root of 33 divided by 6. Right? Now, what happens here? We have a common factor 2 on the numerator because you have 12 and 2. They have a common factor 2. So you can factor 2 out, and you can say this is minus 6 plus minus a square root of 33 over 6. You simplify this, and you will get negative 6 plus minus a square root of 33 over 3. So let's then move forward to the next. The next one is a problem. So this problem is an example of applications of the quadratic equations, right? So they say the length of a vegetable garden is 6 feet longer than its width. So you have a garden, okay? I will erase this part over here. I'm sorry. To have more space, for this to be solved. So we have a garden here that is a rectangular garden. So we have a length and we have a width, right? Now they say the length of the garden is 6 feet longer than its width. 6 feet longer than the width. So L is W plus 6, right? Because the length is 6 feet longer than the width, right? So now I know that I have a rectangular garden with length and width, and the length is 6 feet longer than the width. Now we have the area, and the area is 112 square feet. But what is area? For a rectangle, the area of a rectangle is the product of the length times the width. So it's L times W. So L times W is 112 because area is L times W for a rectangle. So when I find the area of a rectangle, I will say that is L times W. This is area. Right? So that's why I say the area, which is 112, it is saying that L times W is equal to 112. So now I have two important equations here. One equation that is L equals W plus 6, and one equation that is L times W equals 112. So we are going to combine now these two equations, right? So basically what I'm going to do is to substitute L by the expression W plus 6 here, right? So we'll be substituting this L by the expression W plus 6, right? So we say, if I just get this expression and I plug it in here, I get W plus 6, which is L, times W equals 112, right? W plus 6 times W equals 112. Now, you multiply using distributive property. So you say W times W, W squared. W times 6, 6W equals 112. And now, subtracting 112 from both sides to get the equation in a standard quadratic form. W squared plus 6W minus 112 equals 0. And now we can try to factor this. So which are factors of 112 such that the difference between those factors is 6. Let's try with 14 and 8. So we say 14 times 8 is 112. And the difference of 14 and 8 is positive 6 if 14 is positive and 8 is negative, right? So I can say this is W plus 14, W minus 8, like that. 14 times negative 8, negative 112. 14 minus 8, positive 6, right? So I did a factorization. Now, once I have the factors, I say, okay, first factor, W plus 14 equals 0, so W equals minus 14. Of course, W, the width, cannot be negative, right? Because a distance, a length cannot be negative, so I reject this solution. And then the other one say W minus 8 equals 0, so W equals 8. Equals 0, so W equals 8. If W is equals 8, now I say, what about the length? The length, I know that is W plus 6, right? From this equation. So the length would be 8 plus 6, so the length would be 14. So I have now that the width is 8 feet and the length is 14 feet. So what are the dimensions of the garden, of the rectangular garden, you know, that have an area of 112, has an area of 112, right, and has, in this case, dimensions such that the length is equals 6 feet longer than the width, 8 feet by 14 feet. So this is the dimension of the dimensions of the rectangle are those 8 and 14. So it's answer D. So the key here, you know, is given by two sentences, right? So the first sentence is when they say here, oh, the length is 6 feet longer than its width. So from this, I know that L is 6 feet longer than its width is W plus 6. Now, when they say here the area, I know that area is L times W automatically, and is 112. So here I have one of my equations, L equals W plus 6, and the other one, area equals L times W, which is 112. Because always the area of a rectangle is the product of two consecutive sides of length times width. You got it? Now, let's move forward now. Any questions so far? Let me give you time to copy. Let's move now to do some graphing, you know, to work with the graph of linear functions, right? Slope, and all this part. But I think what you cannot do is just to put the plus and minus. So you have to put first positive and later just with the negative sign. But yes. Okay, yeah, because you get the two solutions separated, you know. You don't get the two solutions together, but it's gonna be fine. It's gonna be the same. Now let's look at this other exercise. They say graph the linear function by plotting the x and y intercepts. And look at what they use. Y minus 1/3 x equals 3. Okay? So may I erase this part to have more space here? I don't want that you get confused with these other calculations from the previous exercise. All right, so I will erase this, right? Okay, so here we go. So now they want that I graph by plotting the x and y intercepts, and they give us the linear equation y equals, sorry, y equals no, y minus 1/3 of x equals 3. Now, what we know about the x and y intercept? X-intercept is when y is equal to 0. And y-intercept is when x is equal to 0. So if I want to find the y-intercept, I would make the x 0. If I want to find the x-intercept, I would make the y 0. Right? So finding the x-intercept, if I have the equation y minus 1/3 of x equals 3, making y 0 is a 0 minus 1/3 of x equals 3. So 0 minus that is just minus 1/3 of x equals 3. What do? You multiply both sides by the reciprocal of negative 1/3. And the reciprocal of negative 1/3 is negative 3/1. So we'll multiply by negative 3/1, and then we'll multiply here by negative 3/1. That is the reciprocal of 1/3, of negative 1/3. Now, negative 3/1 times negative 1/3 is going to be 1, because always the product of a fraction times its reciprocal, always a over b times b over 8 is equal to 1, right? What I did here, I just flipped the minus 1/3. I said minus 1/3. When I flip it, it's minus 3/1. This is the reciprocal. I multiply both sides by the reciprocal. And now what I get to the left is just x. And what I have to the right is 3 times negative 3/1, which is negative 9, right? That means that now I have a point that is an x-intercept in negative 9, 0, which is this point, right? In my rectangular coordinate system, this is negative 9, 0. Do you agree? Now, to find the y-intercept, I have to do x equal to 0. So you say y minus 1/3 x equals 3, making x equal 0, y minus 1/3 times 0 equals 3. So negative 1/3 times 0 is 0. So y minus 0 equals 3. So y equals 3. So I have my other point in 0, 3. What is 0, 3? This point over here. So this is 0, 3. And this one is negative 9, 0. Now, the line that I will be graphing now will pass through those points. So we go from let's see if I can just pick a. This is my line now, right? So this is the line that passed through negative 9, 0 and through 0, 3, right? So this line corresponds to y minus 1/3 of x equals 3, right? So my line just looked like that. You got it? Do you agree? Now, the next exercise is about finding the slope. It's about finding the slope, right? So we will calculate the slope of a line. So they give me 2 points. and then we calculate the slope of the line that passed through those points. So remember, the slope is a measure of the steepness of a line. The slope is the change in y over the change in x. So delta y over delta x, right? This is what is the slope, right? So if I have to calculate the slope in my inertial exercise, I know that a slope is delta y over delta x. So the slope is y2 minus y1 over x2 minus x1. Now, what is x1? What is y1? What is x2? What is y2? If I call this point given over here, point 1, x1 would be minus 7, and y1 would be minus 9. If I call this point here, point 2, then x2 would be minus 7, and y2 would be positive 3. Right? So now, once I identify the values of x2, y2, x1, y1, I say y2, 3, minus y1, negative 9, over, then x2 minus 7, minus x1 minus 7. So 3 minus negative. So 3 minus negative 9. That would be 3 plus 9, right? That would be 3 plus 9. And now, negative 7, negative 7 is positive 7. So I get 3 plus 9, 12, over negative 7 plus 7, 0. 12 over 0 is not a number. So 12 over 0 is what we call undefined. So remember, 12 over 0, not a number. That's why it's undefined. 0 over 12, that is 0. 0 over 12 is 0. Right? But 12 over 0 is undefined. So right answer here, this slope must be undefined. Okay? We got this one? Do you understand? So we have calculated the slope. In this case, we found the slope is undefined. When the slope is undefined, it's because the line is vertical. You know, the slope is undefined for vertical lines. Let's see the next question. So next question. Next question, they give us 2 points on a line and they say write the equation of the line. So what I know about this line, I know the coordinates of these 2 points. I know the point negative 5, comma negative 1 is on the line. I know the point negative 3, comma negative 4 is on the line, right? So when they give me 2 points, so you say 2 points on the line are given. So if 2 points on the line are given that are negative 5, comma 1 and negative 3, comma negative 4, I will find the slope I will find the slope, right? The first I'm going to do with that is to find the slope. So when I find the slope, I say, oh, slope m is equals delta y over delta x. As we said, y2 minus y sub 1 over x sub 2 minus x sub 1. Now, we is x1, y1, x2, y2. Okay, we say this is x sub 1, this is y sub 1, this is x sub 2, this is y sub 2, because this point would be my point 1, this would be my point 2. So the x of the point 1 is x1, the y of the point 1 is y sub 1. The x of the point 2 is x sub 2, and the y of the point 2 is y sub 2, right? But I can say that this one is point 2 and this one is point 1, and that is not going to change anything. It's going to be the same equation, it's going to be the same result. Okay? So, but once I fix, the values, when I assign the values of x, when I assign the values to x1, to y1, to x2, to y2, now we have to substitute here using those values, right? So we say, okay, this would be y sub 2, negative 4, minus, what is y sub 1? 1, over x sub 2, negative 3, minus f sub 1, negative 5. That means that I have negative 4 minus 1, negative 5, and negative 3 plus 5, because negative here become positive. Negative 3 plus 5 is positive 2. That means that my slope is then negative 5 over 2, right? This is the slope. Negative 5 over 2. So if the slope is negative 5 over 2, now I am ready to find with the slope and 1 point the equation. So now find the equation using a slope and x1 comma y1. So that means that I say, okay, now form point slope form of the equation of the line. Y minus y sub 1 is equal to the slope times x minus x sub 1. So y minus, what is y sub 1? We said that y sub 1 is 1, equals a slope negative 5 over 2 times x minus, what is x sub 1? Negative 5. Right? So I substitute y sub 1 by 1 and x sub 1 here by negative 5. So I say y minus 1 equals negative 5 over 2 times x plus 5. Now, multiply using distributive property. So you say, okay, I will multiply this here. So we say, okay, this would be y minus 1 equals negative 5 over 2 times x, negative 5 over 2x. Negative 5 over 2 times 5, negative 25 over 2. Right? And now we're going to be adding 1 to both sides. So we'll be adding 1 to remove the 1 from here and get the 1 on the right side. So we say y equals negative 5 over 2x minus 25 over 2 plus 1. Now, how do you perform this operation? Negative 25 over 2 plus 1. You need to multiply the 1 by 2 over 2 because you need to have the same denominator, because 1 is 1 over 1. I cannot add these numbers because I have different denominators. So remember, from the previous algebra that you multiply here by 2 over 2, and the previous algebra that you multiply here by 2 over 2, and now you get negative 25 over 2 plus 2 over 2. which is negative 25 plus 2, negative 23 over 2, because now you have the same denominator. So that means that this is negative 23 over 2. So you can rewrite the equation like y equals negative 5 over 2x minus 23 over 2. And here I have the equation of the line that passed through those points. So always I have first to find the slope. I have to find the slope first. And after finding the slope, then I can find the equation using the slope and one of the points. Remember that this equation that I use over here is called point slope form. Point slope form of the equation of the line. This is the point slope form. Got it? So the most problematic part here really is when you have to add the fractions. If there are fractions, you know, that could be the most confusing part. But remember, right, you have the calculators. So you have scientific calculators. So scientific calculators should be able to do those calculations without any problem and give you the answer in the form of a fraction. So you should be fine from that point of view. So right answer here should be answer A, right? Let's do the next one. Now, look at this one. They say, find the slope and the y-intercept of the graph of the equation, right? So they give us here one equation. There is x plus y equals 6. And they want me to find the slope and the y-intercept. So what happens? I know that this is the slope-intercept form of the equation of the line, y equals mx plus b, where this is the slope, m is the slope, right? And b is the y-coordinate of the y-intercept. So y-intercept is 0, b. This is y-intercept. So what I have to do if I want to find the slope and the y-intercept, I will solve for y. So I will try to get the y by itself here. What I have to do if I want to solve for y, I will subtract x from both sides. So we say y is equals, subtracting x, I get minus x plus 6. In front of this negative sign, in between this negative sign and the x, there is a 1, right? Here there is a 1. When no coefficient, is because the coefficient is 1. So this is the same that y equals minus 1x plus 6. So this coefficient of the x is the slope. So a slope for this equation, a slope m is equals minus 1. You know, is the coefficient of the x. And y-intercept would be, remember, 0, b. This number is b, so 6 is b. 0, b would be 0, 6. So y-intercept would be 0, 6. Because it's 0, b. So I have a slope -1, y-intercept 0, 6. right? So a slope -1 intercept 0,6 is this answer, answer C. We got it? So when they give you an equation like this one, and they say find the slope, the y-intercept, you know, what do you have to do? You have to solve for y. You have to isolate the y. So you have to rewrite the equation in the slope-intercept form. This is the way just to be able to find the slope and the y-intercept. No, coño. No, hace más esto, dice. Now, look at this one. Use the slope and y-intercept to graph the function. Now, what is this? Now they give me the function, right? They give me the equation of the line. Y equals, or f of x equals 2x minus 1. I want to graph it, right? So this 2 is the same that 2 over 1. And that is the slope. So slope 2 over 1. But remember that that slope is the rise over run. Now, this -1, I said that is the y-coordinate of the y-intercept. So 0, -1 is the y-intercept. Because this number is always b. Is the y-coordinate of the y-intercept. So what do you do to graph the function? Is you know the slope and the intercept. You graph the intercept. You plot the intercept, 0, -1. This is my intercept. Now the slope is rise over run. So that means that I will go 2 units up, and the run is just horizontally and 1 unit to the right. And like that, I can go again, 2 up, 1 to the right, 2 up, 1 to the right, and like that. So we go 2 up and 1 to the right. My next point is over here. You know, look at this. I went 2 units up, 1 here, another 1 here. So 2 up and 1 to the right. I can go 2 up and 1 to the right again. So 1, 2, 1 to the right here, my next point. 2 up and 1 to the right, my next point. Or I can go 2 down and 1 to the left, 2 down and 1 to the left, because I can do also this. I can go 2 units down and 1 unit to the left. So 2 down and 1 to the left. So all these points that you see over here are points on the line. So I can just get the line here. And I say this is my line. You got it? Let us solve one more exercise before getting the break. So let's see the next one. They say using the slope form, use the point and slope form to find the equation of a line with the given properties. Write the equation in a slope intercept form. So they say a slope -4 through 5,8. When they say use point and slope form is y minus y sub 1 equals a slope times x minus x sub 1. This is the point and slope form. So what we have to do, we say, oh, okay, I will say y minus y sub 1 equals the slope times x minus x sub 1. Now, what is the slope? As you can see here, slope is negative 4. So this value would be negative 4. Now, passing through 5,8, this would be x1. And then this one would be y sub 1. So we'll be substituting this number by 8. And I will be substituting this one by 5. Right? So I can say that this is now y minus 8 equals negative 4 times x minus 5 equals negative 4 times x minus 5. Y minus 8 equals, you multiply negative 4 times x, negative 4x, negative 4 times negative 5, positive 20. And now we're adding 8 to both sides. So we say y equals minus 4x plus 20 plus 8. So y equals minus 4x plus 28. And here I have the equation of the line.
Teacher, what the answer? Sorry, I can see.
What?
The 16.
Oh, the 16. This one is a graph, the answer. Exercise number 16 is a graph.
Oh.
So it's not a choice, right? This one is not multiple choice. The graph is there in the answer key, right? Right? Do you have the answer key there? So number what? 16 was this one, right? Pass through negative 1, pass through all these points. Oh. It's this one, right? What? This? Yes. Now, right answer in this case, when they say write the equation in slope-intercept form, is answer D, right? This here is answer D. Do you agree? Number 18. So, more lines. So there are a lot of exercises here about lines, right? So these are exercises about perpendicular or parallel lines, okay? So remember that when two lines are parallel, we have parallel lines that are lines that never meet, right? In this case, the slope of the two lines are equal. So you have two lines, line 1 and line 2, right? And if the lines are parallel, the slope of the lines are equal. Now, when the lines are perpendicular, the slope of one of the lines is the negative reciprocal of the slope of the other line, right? So the slope of one of the lines is a negative reciprocal of the slope of the other line. So now they give us here two lines. One line, there is 2x minus 5y plus 20, and one line that is y equals 5 over 2x plus 3. And they want me to define, right, if the lines are parallel, perpendicular, or neither. So what I have to do, this one is evident what is the slope. The slope here is 5 over 2, right? Because what is the slope? This is the slope, right? This number is the slope. 5 over 2. Now, in the other one, they don't give me this other equation in the slope-intercept form. So I have to solve for y. So I have 2x equals minus 5y plus 20. So what I'm doing, I would be subtracting 20 from both sides. So we say 2x minus 20 equals minus 5y. And then I will divide by negative 5 both sides. So when I divide by negative 5, I say this is 2 over negative 5x, and then negative 20 over negative 5. This is equal to y. So negative 20 over negative 5 would be positive 4. So I get that the line is negative 2 over 5x plus 4 equals y. So in this other line, the slope is this negative 2 over 5. This is the slope, right? So I have a slope 5 over 2 here for this line, and for the first line, I have a slope negative 2 over 5. So this slope is negative reciprocal of this other. This slope is negative reciprocal of this other. Why? Because if you get and you flip 5 over 2 and reverse the sign, you get minus 2 over 5, right? So when you flip 5 over 2, you get 2 over 5. If you reverse the sign, positive 2 over 5 turns into negative 2 over 5. So we have then, the same slope. If you flip and reverse the sign. So this one is negative reciprocal of this one. So the lines here are perpendicular because one is negative reciprocal of the other one, right? So do you want to see how you can also find that? You say, okay, I found this slope. So I will say that that is the slope 2. So we say, okay, slope 1 is negative 1 over the slope 2. If I substitute now this by negative, this is slope 2 by negative 2 over 5, negative over negative is positive, and then you have to flip and multiply. So this is saying that negative 1 times negative 5 over 2, negative times negative is positive, and 1 times 5 over 2 is 5 over 2. So you can see I get the same thing. So it's true that this one is negative reciprocal, right? So this is what is negative reciprocal. You flip and reverse the sign. The sign was positive, you just turn negative. If it's negative, you turn into positive. So these two are perpendicular. Now they give me these other two. Here, again, easy. This one is pretty clear that the slope is 5 over 2, right? Because the slope is this number. What about the other? The other line is minus 5x plus 2y equals minus 2. So I have to solve for y. I have y. I will be adding 5x to both sides. So I say 2y equals 5x minus 2. I will be dividing by 2 both sides. Y is equals 5 over 2x minus. I am dividing by 2, 2 over 2. So y would be equals 5 over 2x minus 1. This number doesn't matter. What matters here is just the slope. So we look at this slope is 5 over 2. The slope that I have for the other one was also 5 over 2. So these lines are parallel. These lines are parallel. Why? Because we get the same slope when we solve for y. So how do you find, what is the slope when the equation is given in this form or in this order? Just solve for y. So try to isolate the y. Try to get the y by itself. Right? Like that is that you just get easily the value of the slope. Because the slope will be always the coefficient of the x. Okay? So in the first case, the lines are perpendicular. In the other case, the lines are parallel. When the slopes are equal, lines are parallel. When one slope is negative reciprocal of the other, lines are perpendicular. Now, any questions so far? Let us see now exercise number 20. So in exercise 20, yeah, of course. Yep. In exercise now number 20, they say find the equation of the line with the properties given and write the equation in the form indicated. So they say through 4,5, a line that passed through 4,5 and is perpendicular to the line whose equation is y equals 1 over 8x plus 7. So the key here is this. When they say that my line, the new line that I will find, is perpendicular, when the new line that I will find is perpendicular to this line, if the slope of this line, if the slope of this line is 1 over 8, this is the slope of given line, then the slope of the new line would be flip and revert the sign. So 1 over 8, when you flip it, is 8 over 1. When you reverse the sign, is minus 8 over 1, so it's minus 8, right? So this would be the slope of the new perpendicular line. Right? So always, because they say perpendicular. So they say, oh, it's perpendicular to this one. What I have to do, I have to get this slope, flip, and change the sign. So 1 over 8, when I flip, is 8 over 1, which is 8. When I reverse the sign, minus 8. So the new slope is minus 8. Now, what else? The line passed through 0.4,5. So 4,5, which is x sub 1, y sub 1, is a point on the line. So once I know that, I say, oh, if I want to find the equation of that line, I have to use the Pointer's law form. So y minus y sub 1 is equal to slope times x minus x sub 1. So y minus, what is y sub 1? 5 is equal to slope minus 8 times x minus x sub 1. What is x sub 1? 4. Now, y minus 5 is equals negative 8 times x, negative 8x, negative 8 times negative 4, positive 32, right? And now adding 5, y is equals minus 8x plus 32 plus 5. So y is equals minus 8x plus 37. Now, what they said, write this in function notation. If they say function notation, right, it needs to be f of x instead of y. So we say, oh, function notation, This is f of x equals minus 8x plus 37. So what is the right answer? Right answer should be answer D. Remember that functional notation use the f of x. We got it? Yeah, of course. Yeah. Now, after that, we have operation with functions, right? So we have operations with functions. So we have some exercise about operation with functions. So we know what a function is anyway. There are exercises later to see about functions, right? If you want, we can skip a couple of these exercises and we can come back later to this exercise, once we discuss quickly what are functions, right? In the next page. So let's do something. Let us go to this other exercise, right? And then we're going to find, if function or not. We're going to discuss about the classification of function, and we can come back to do 21 and 22 later. So let's see here. I'm going to also skip this one. So we go to 24. Remember, we still have pending 21, 22, 23. So they say determining the relation illustrated is a function, give the domain and range of the function or relation. So now remember, we have a function of x into y. So we have a function of x into y when for each value of x there is one and only one value of y. When for each value of x there is one and only one value of y. So here they say if this is a function, well, we have here one element. We're going to call this set x or domain, and this set y. We have this element of x here that is in a correspondence with two elements of y. So by definition, this should not be a function. This should not be a function, right? Because we have one element of x with two elements of y in a correspondence with two elements of y. And they are very clear here in the definition. They say for each value of x, for each element of x, there is one and only one value of y. So they have to be a one-to-one correspondence, from x to y. So this should not be the function. Now, when they say, what is the domain? The domain are Alice, Brad, and Carl. And what is the range? Snake, cat, and dog, right? So what is the right answer should be D. It's not a function. Domain, the elements of x, Alice, Brad, and Carl. And range, the elements of y, snake, cat, and dog. Agree? So this is what the definition of function basically is, right? Now, let's see what they have in the next one. We're going to come back later for those other exercises. But let's see first this one. Now, they give me here the graph of a function. Why I know that this graph is the graph of a function? Remember that we have a test that we know that is the vertical line test, right? But we said we do vertical lines, and if each vertical line is intersecting the graph at only one point, the given graph is graph of a function. So when you look for the point of intersection with the vertical lines, each vertical line is intersecting the graph at only one point. So it's evident that this graph is the graph of a function, right? It's the graph of a function, so no discussion about it. Now, they want to find what is the domain and the range for this function. So remember that the domain, we go from the lowest x value to the highest x value. Now, parenthesis or bracket, it will depend on what kind of symbol we have in the extremes, right? What kind of symbol we have in the extremes of the graph. When the symbol is like this, that is a closed circle, that means that the interval is closed. And if the interval is closed, you have to use a bracket. And the same story over here. So it's a closed circle. So the interval is closed at that extreme. And if the interval is closed, then we're going to use a bracket also in this extreme, right? If we have open circles like this, so suppose that instead of this one, you have something like this, it would be a parenthesis. If you have an arrowhead, then it will go to infinity, and it will be a parenthesis also, right? Now, when we understand that, we say, okay, but for this specific graph, what is the domain? Okay, so for this graph, what is the lowest x? The lowest x is minus pi, right? So minus pi is the lowest x value. So it goes from minus pi to what is the highest x value? This one corresponds with pi. So it goes from minus pi to pi. Now, closed circle, I will put a bracket over here. I will put another bracket over here. So what is the domain? The domain of this function goes from minus pi to pi. From minus pi to pi. This is a sinusoidal function that has a horizontal shift. Or have a reflection, maybe also, right? It's another choice. So this is, what the domain of this function is. Now, when we look for the range, now the range of the function go from the lowest y value to the highest y value. From the lowest y value to the highest y value. So what is the lowest y value? Y corresponding to this point. And the y corresponding to that point is minus 1. Right? Sorry. And what is the highest y value? The highest y value is the y corresponding to this point. And what is that y value? 1. So this graph is a graph that is oscillating between -1 and 1 all the time. So will be contained in between these two y values. It's a graph, you know, that if you extend it beyond the pi and the minus pi, it will be periodic, right? Periodic because it's repeating in every period. And it would be always between -1 and 1. So what is going to be the range with brackets from -1 to 1? So it is a function. It has a domain. The domain is given by the x variable between -pi and pi, including pi and -pi, and it has a range with the y variable, right? And it's between -1 and 1, including -1 and 1. So what is the right answer? This is the right answer. So you also have to be able to understand, you know, when a different notation is given. This notation is the set builder notation, right? So this same thing can be written like x such that -pi lower than or equal to x lower than or equal to pi. These two things are the same. So to the left, we have the interval notation. To the right, we have the set builder notation. Now, here, this is the same in set builder notation that the set of all y such that -1 less than or equal to y less than or equal to 1. Right? -1 less than or equal to y less than or equal to 1. So what is the right answer? This one. So I know it's a function. So once I define that it's a function, I said this is say not a function, this one say not a function, so these two are wrong. So why I know immediately without thinking too much that this answer A is wrong? Because they say domain, the set of all y. No. The y is never domain. The y is range. So when they say domain y, set of y, I say no, it's wrong. Right? So you have to, you know, use all these tips in order to find the right answers, right? Now, look at this. Now here, they say evaluate the function for the indicated value. Evaluate the function for the indicated value, right? So I have to evaluate. Evaluate is basically to find the value of the function. Is to find the value of the function for the given value of the variable, right? So what they say here, find f of 4. Look at this, find f of 4. So I have to find f of 4. F of 4 is evaluate the function f of x equal x squared minus 5x plus 5 when x is 4. So we say, oh, okay, this is f of x equals, or f of 4, right? Because we're going to evaluate at x equal 4. We're going to say f of 4 equals, so x squared, no, we substitute the x by 4. So 4 squared minus 5 times 4 plus 5. So I have substituted the x here by 4. I have substituted this x also by 4. You know? So now we say 4 squared, 16. Minus 5 times 4, 20. Plus 5. Right? 16 minus 20 plus 5. Now, what is 16 minus 20? Minus 4. Plus 5. Minus 4 plus 5? 1. So what is f of 4? 1. So what should be the right answer? Should be answer D, right? So 4 squared 16 minus 4 times 5 is minus 20. 16 minus 20 minus 4 plus 5 is 1. So f of 4 is 1. Now, f of negative 2. Next, f of negative 2. Have a new function, x to the third plus 6 over x squared minus 8. You say, okay. F of negative 2 is negative 2 to the third plus 6 over negative 2 squared minus 8. So I have replaced the x by negative 2. Negative 2 to the third power. Remember that negative 2 to the third power is negative 2 times negative 2 times negative 2. So you have 3 factors negative 2 that you multiply. So that would be negative 8, right? So that means that negative 2 to the third is negative 8 plus 6 over. Now, negative 2 squared. Negative 2 squared, remember that is negative 2 times negative 2, which is positive 4. So you get 4 minus 8. Now, minus 8 plus 6 minus 2 over 4 minus 8 minus 4. Negative over negative, positive. 2 over 4, we simplify. Dividing by 2 is 1. Dividing by 2, 4 divided by 2 is going to be 2. So what is the value here? Positive 1 over 2. So f of minus 2 is positive 1 over 2. Should be answer B here. Do you agree? Now, let's go back to the question that we skipped. Yeah? Down, up, up, there, a little bit more.
Yes.
Like this.
Yes. The answer, oh, is C. Okay. Yeah.
Up.
Okay.
Okay, so let us go back to the question that I skipped, right? So I just skipped number 21. So now we're going to do it. So what happened here? Here we have to find an operation with functions, and also I have to evaluate. So they give me two functions. One function is, look at this, one function is f of x equals 12x squared minus x minus 1. The other function they give me is g of x equals x squared plus 8x plus 10. So there are two functions here, right? Now what they want to find f plus g of x. This is the first that we have to find. F plus g, this is the first that we have to find. F plus g of x. Now remember, f plus g of x is f of x plus g of x. What I have to do? Basically adding the two functions. So we say, what is f of x? 12x squared minus x minus 1 plus, what is g of x? X squared plus 8x plus 10. So what is now this? I will remove the parentheses, so I get 12x squared minus x minus 1 plus x squared plus 8x plus 10, and 12x squared plus 1x squared is 13x squared. Now minus x plus 8x is going to be positive 7x. So remember that you are adding polynomials now. Minus 1 plus 10 is positive 9. So that means, right, that this expression that you see here is f of x. So, sorry, f plus g of x. So f plus g of x is 13x squared plus 7x plus 9. Okay, this is my f plus g of x. That was the first that they asked. What they asked later, what is f plus g of a? When they say f plus g of a, they want that you get this f plus g of x, and you will evaluate this at x equal 8. So you will replace the x by 8, right? So when now I find f plus g of 8, I just basically get my function f plus g of x, and I substitute the x by 8. So I say this is 13x squared, no, now it's a squared, plus 7x, no, now 7a plus 9. And that's it. This is my f plus g of a. So it was not a big deal. And what else they ask you? Find f plus g of 2. F plus g of 2. F plus g of 2. That means that I have to go and get the function f plus g of x, and I will evaluate that function when x is 2, right? So f plus g of 2 is 13 times, replace the x by 2, 2 squared, plus 7 times, replace the x by 2 times 2, plus 9. So 2 squared is 4, so it's 13 times 4 plus 7 times 2 plus 9. 13 times 4 13 times 4, 4 times 3, 12. Carry 1. 4 times 1 is 4, and 1 is 5, 52. Plus 7 times 2, 14. Plus 9. So 52 plus 14 is 66, right? 66 plus 9 is 75. That means that f plus g of 2 is 75. Now, what is the right answer? I think it's answer B, right? Okay. 13x squared plus 7x plus 9. F plus g of 8, 13a squared plus 7a plus 9. And f plus g of 2, 75. So what is the right answer? Answer B. We got it? Do you agree? So this is an operation, these are operation with functions. What are we doing here? Adding functions, right? Adding functions. Now next, f times g of 2. They give us two functions now. Look at this. They give us this function here, that is f of x equals x minus 4. And they give us this other function, that is g of x equals 2x squared plus 13x minus 5. What they are asking for f times g of 2. F times g of 2. So we're going to multiply f times g. So we're going to find f times g of x. I know that f times g of x is f of x times g of x. So I will multiply the functions x minus 4 times negative 2x squared plus 13x minus 5. When I multiply here, I use the distributive property. So we multiply first times first, the first times the second, the first times the third, later the second times the first, the second times the second, the second times the third. So we say, okay, this is x times negative 2x squared plus x times 13x plus x times negative 5 minus 4 times negative 2x squared minus 4 times 13x minus 4 times negative 5. So now, negative 2x squared times x, negative 2x to the third power. X times 13x, 13x squared. X times negative 5, negative 5x. Negative 4 times negative 2x squared, negative 4 times negative 2, positive 8x squared. Negative 4 times 13x, negative 52x. Negative 4 times 13x, negative 52x. 4 times 3, 12, 4 times 1, 4, and 1 is 5. And negative 4 times negative 5, positive 20. I still have to combine similar terms. So f times g of x would be negative 2x to the third. 13x squared plus 8x squared would be 21x squared. Negative 5x minus 52x is negative 57x plus 20. Do you follow me? So we have now f times g of x. Now we're going to evaluate when x is 2. So f times g of 2 is negative 2 times 2 to the third plus 21 times 2 squared minus 57 times 2 plus 20. So 2 to the third is 8 times negative 2, negative 16. 2 squared is 4 times 21 is 84. Negative 57 times 2 is negative 114 plus 20. Right? Now, so I know that 84 minus 114, I'm going to violate now the order of operations, right? Because I'm supposed to go from left to right. But I don't want to use my calculator, so I'm going to say that this is minus 30 here, minus 16 is minus 46, minus 46 plus 20 is going to be minus 26, I think. So this should be the answer D. So of course you can put the numbers in the calculator, you know. I just make a quick operation. I believe there is negative 26, the right answer, you know, when you evaluate that. Now, there is another way to do this that will be probably easier. Huh? Okay, so there should be another way that would be probably, well, this is not hard. What we did wasn't hard. It was just involved a lot of work because we had to do a lot of multiplications. right? And combine a lot of terms, and can be confusing and dangerous sometimes because it's very easy to make a mistake with a sign, with an exponent. So there is another way to do this. That is, if I have to find f times g of 2, f times g of 2 should be equal to f of 2 times g of 2. So if I find f of 2 and I multiply f of 2 times g of 2, I should be able to find the same number. So let's see if it's true. F of 2 is 2 minus 4, which is negative 2, because f of x is x minus 4. So I substitute this x by 2, I get 2 minus 4, this is minus 2. So this is f of 2. Now g of 2, I will substitute the x by 2 here. So we say negative 2 times 2 squared plus 13 times 2 minus 5. This will be 2 squared is 4 times negative 2 is negative 8. 13 times 2, 26, and minus 5. So negative 8 plus 26 is going to be negative 18, and negative 18, sorry, positive 18, negative 8 plus 26 is positive 18, and positive 18 minus 5 is positive 13. That means that now I know that f of 2 times g of 2 is negative 2 times 13 is the same negative 26, right? So it was shorter, was faster, and was easier. It was only to evaluate f of 2 and g of 2, and you multiply.
This is the easy way.
This is the easy way, yeah. Because what I did, I just evaluate f of 2, I evaluate g of 2, and I multiply the results, and that's it. Here, I found the actual product of the two functions, which was this expression over here. And then later, I evaluate when x is equal to in that expression, which was, a little bit crazy, right? Yeah, I know, me too. Believe me, I know it. I start today, like at 8. I was in the mornings. I have just on Tuesday and Thursday. I have a physics class here. So I start at 8. From 8 to 12. Later, I had a lab after that from 12 to 2 p.m. with the same students. So they I don't know, they show up sometimes. Sometimes they don't show up. I know it's 6 hours in line, right? And then at 5, I came back here. So I went to my house, got something, took a bath, and came back. So I am just today, I feel like my body is just like it's completely dry from here to here. I think I feel like el desierto del Sahara. But estás garganta seca completa, pero we have to keep moving. So we have no choice. Now, but it's important to do these reviews, because we see different exercises. We like to put some order in what we have learned, which is, let's try to do is 8:40. We still have like 15 more minutes until 8:55. We're not going to have time to solve all the exercises, but at least we're going to solve maybe 4, 5, 6 more exercises, right? So let's try. May I move forward to the next?
Yeah, I got it.
All right, so let's do this one now. I will recommend you something. I share. I don't know. I think I shared a video with you, right? About how to use the ChatGPT as a tool.
Yeah.
Did you try?
I'm trying today.
Did you try to use it? And it worked? You can remember that the key is you have the answer key. The key of this is just to put the question and say, okay, this is the question. I know this is the answer. So show me the steps. Show me how to do it, right? So because it get confused sometimes. So remember, the AIs are not really the strongest part of the AIs is no calculations, right? They are not good to do calculations. They have to do some things in the background before doing those calculations. That is just creating code in Python. So that is a little bit crazy for them, right? For the AIs, but it helps really because it can show you how to solve some exercises, right? So I recommend you, just to try that. If we don't have time to solve all the exercise, you can just go and show some of the exercise to the AI and ask it, to solve some of the problems. Now look at this one. We did a lot of exercise like this one in the other day here in classes, right? Do you remember? Here they say find f plus g of minus 5. So they don't want that we just find all the values, right? They want that we just find f plus g at x equal minus 5. So what we do, we say, okay, I have a function f that is this one. So the function that I will put in red is the function f. Sorry, let me just do the line here. Better. This one, oh, sorry. This one is my function f. And now the function I will put in green is the function g. I took green, the other one. Come on. You are red. Why are you green? They say you are red. You are red. Right? And then the green is the other. This is the green. But the part that matters is just there in the left. So this is G. And this one is F. So they say F plus G of minus 5. So what do? You go here to x equals minus 5. Right? And you say, what is the value of the function f? When x is equals minus 5, the function f is equals to 1. Right? Now, when x is equals minus 5, the function g, that is the green, we go up. This is 7. So g is 7 when x is equal to minus 5. Right? Look at this point. That is the intersection of minus 5 with the green graph. And then when you go to the y-axis, it shows that the value of the function is 7. So if I have to find, f plus g of minus 5, this would be f of minus 5 plus g of minus 5. And f of minus 5, we said that is 1. And g of minus 5, we said that is 7. So this is 1 plus 7, this is 8. So remember that we did the calculations here the other day. So we were just point by point adding the two functions, coordinate by coordinate. In this case, they don't want that you find, every single coordinate. They want that you just find, when x is minus 5, what is f plus g of minus 5. So we find the value of f at x equal minus 5, which is 1. We find the value of g at x equal minus 5, which is 7. And then we add 1 plus 7, and 1 plus 7 is 8. So we get answer A, answer C. We got it? We did a lot of exercise like that the other day.
This is a little easy.
Yeah, it's not that hard. So let's go back now. And now let's start doing some of the quadratic functions here. So now this is quick, really quick. They say this one, determine whether the parabola opens upward or downward. This one, the first one, downward. Why downward? Oh, yes, because of the negative sign here, right? So this negative sign that we have over here, say that is downward because it's negative, right? Now here, what about this? It's positive, right? So this one opens upward, right? So this opens upward. This is downward because it's negative. This is upward because it's positive. Yeah. Remember the functions are y equals ax squared plus bx, the quadratic functions, plus c. And I said, when a is greater than 0, so when it's positive, the graph of the function would be something like this. Opens up.
Oh, okay.
Now, when is a less than 0, when it's negative, then the graph of the function will open downward. So the parabola would be opening like this, right? Mm-hmm. So downward means that opens like this, and this is when this number, the leading coefficient, that is this coefficient over here, is negative. The sign of the x squared. Here there is positive 4 over, negative 1 down. Got it? Good. Now look at this one. They say, they give us this function f of x equal x squared plus 8x. And they say find the vertex and axis of symmetry of the graph of the function. So remember, vertex. We have an equation, we have a formula to find the vertex. Vertex is at h, k. This is the vertex. Now h is negative v over 2a. Right? Now, what is b here? Here, b is 8, a is 1, 8, a is 1, right? Okay, a is 1 because there is no coefficient. So when there is no coefficient, it's because it's 1, right? So b is 8, here a is 1, and c is 20. But I don't need c. So I say h, the x coordinate of the vertex, is negative v over 2a. So it's negative 8 over 2 times 1. So it's negative 8 over 2, which is negative 4. Now, what is k? K is f of h. K is f of h. So it's f of negative 4. It's f of negative 4. So what are we doing? We evaluate the function at x equal negative 4. So when we evaluate the function at x equal negative 4, I say this is negative 4 squared plus 8 times negative 4 plus 20. Negative 4 squared, 16. 8 times negative 4, negative 32 plus 20. 16 minus 32 is negative 16. Negative 16 plus 20 is positive 4. So that means that your vertex is at negative 4, 4, right? Negative 4, 4. There is the vertex. Now, what is the axis of symmetry? Axis of symmetry is x equal h. So it's x equals negative 4. It's the equation of a vertical line. So what is the axis of symmetry? Negative 4. What is the vertex? Negative 4, 4. The right answer should be D. No, sorry, B, the C. Come on. I'm going too quick. So should be C. Negative 4, 4 with x equal negative 4. We got it?
Yes, teacher.
So this is vertex, negative v over 2a. K is f of h.
Muita informação para o cérebro. Teacher is B?
C, answer C, right?
The C?
Yep. Negative 4,4 and x equal negative 4. Now, similar to that is the next one. That is going to be the last one we're going to solve because we don't have time for more, really. So we can do, for this one, we can do the same. So we can find the vertex in the same way. So now in this one, just going quickly over some of these, right? Here you have that A is 4 and B is 24. So you want to find the vertex. You have that A is negative V over 2a. So it would be negative 24 over 2 times 4, which is negative 24 over 8, which is negative 3, right? And then K would be f of h, which is f of negative 3. So you will evaluate the function, this, when next is negative 3. So you will substitute the x by negative 3, you will solve, right? And you will get then what is the value of K. And the axis of symmetry, of course, will be x equal h. So the axis of symmetry would be x equals minus 3.